teacher!
Hey guys, in this video we're going to be solving linear systems graphically. I did make a handout for you to make the task part of your notes easier. It's posted on the website, and we're going to be going through the terms today. So, a couple of new terms. There's point of intersection. That's the point where two or more lines cross. And a linear system is a set of two or more linear equations that are considered simultaneously, and simultaneously means at the same time. So in a nutshell, if you're solving for a linear system, it just means that you're finding the point of intersection between two lines. So what does that mean? If we have two lines or even three lines or something, a linear system can have 0 solutions, 1 solution, or infinite solutions. And if it's 0 solutions, if we're solving for a linear system, that means that there is no point of intersection. There's no solutions there. So the kinds of lines that don't intersect are parallel lines. By definition, parallel lines do not meet. They never intersect till infinity. So if they are parallel lines, they will not have a solution. It's 0 solutions. If it's 1 solution, those are non-parallel lines. This is typically the situation that you're going to see in most standard questions, but 1 solution for all linear equations, there's just 1 point of intersection. If there's infinite solutions, that means that you have many different points of intersection till infinity. So it's actually having 2 identical lines. You might be like, well, that's just the same as having 1 line, but you can have 2 lines stacked on top of each other, you just might not know it. So for example, if I had 2y equals 4x plus 3, I have another line, y equals 2x plus 3 on top. But if you solve for y, you'll know that those are the same lines, and that's why we say there's infinite solutions, because they're meeting each other along the line till infinity. So here's an example of a typical question you might see. Solve a linear system by graphing and check that you're correct. You'll see this symbol. This means that this is a linear system. Similar in music, if you have the bars of treble clef and bass clef, you have a system there. It's the same with linear systems. So we have y equals half x minus 3 and x plus y equals negative 6. You should notice that the second equation is in standard form. So if I have it in standard form and I want to graph it, that is the signal that you need to convert this standard form into slope y intercept, because it's just much easier to graph. So I'm going to do that now. This case is really easy. I'm just going to bring the x to the other side and it becomes negative. So y equals negative x minus 6. What is the slope of this line? It is negative 1. Very good if you got that correct. So now it's much easier for me to graph these two equations. So in the first one, and I'm going to do it in red, y equals half x minus 3. So my slope, my y-intercept, or my initial value, is negative 3. So on my graph, I'm going to plot a point at negative 3. My slope is 1 over 2. So my rise is 1, so I'm going to go up 1. And my run is 2. So I'm going to go to the right 2. And I know that the slope is positive, because as my x value is getting bigger, my y value is also getting bigger, or it's going to the top right corner. So you can check when you're graphing that you're actually graphing correct by checking to see if your slope is correct. So my line looks something like this, and yours should too. So if we're graphing the other part, my y-intercept, or my initial value, is negative 6. So I'm going to put a dot at negative 6. And my slope is negative 1. So I can go down or I can go left for my rise. I'm just going to go down 1. And I'm going to go to the right 1. And I know that this is negative because it's going down towards the bottom right. As my x values are getting bigger, my y values are getting smaller. That's how you know you have a negative slope. So if I extended the two lines, it's very clear where the point of intersection is graphically. It's just right here. So this point is at -2, -4. So in my therefore statement, therefore the POI, or point of intersection, is -2, -4. So you need to write this out if this was on a test. Most of the work is graphing, so this is where most of the marks are going to be, and your conversion would also be a mark if it's in standard form. Now the second part of the question was check that you are correct. This goes back to when you were solving equations. You're checking that your left side is equal to, it's checking that your left side is equal to your right side. So I'm going to put the left side equation as this one. It's already in slope y-intercept form. So half x minus 3 should be equal to your negative x minus 6. And since I know what my x value is already, I'm just going to plug that value in. So 1 over 2 times -2 minus 3, and the right side is -2, because that's my x value, minus 6. 1/2 times -2, you should realize that that's -2 over 2, which simplifies to -1. From this point, you don't need to show me this anymore. You should be really comfortable with that, and if you're not, maybe go refresh how to do those. And -2 is +2 minus 6. -1 minus 3 is -4. +2 minus 6 is also -4. So clearly I am correct because both sides equal each other and it matches my graph. The extension of this is not required in grade 9. It's instead of graphically doing it, you're algebraically doing it. I'm just going to go through this with you anyways because it's good to know. You're going to need to know it in grade 10. So it's kind of very similar to what you did for the check. You're going to make both sides equal each other. Both are going to be in slope y-intercept form. So I'm just going to recopy what our conversion was here. And we're pretending that we don't know what x is. So we're going to do the same thing, except instead of left side, right side, we're going to make it equal to, because that's by definition what a point of intersection is. It's where both of the lines equal each other. So I want to put all of my x's on the same side. So I'm going to bring this negative x over to make it positive. So 1 over 2x plus x equals, and I'm bringing the -3, and it's going to also become positive. So -6 plus 3. Half x plus x, if you wanted to convert this into a fraction, you could. It would be 2 over 2. So 1 plus 2 on the top is 3. We don't add the bottoms. That was our common denominator. So 3 over 2x is equal to -6 plus 3, which is -3. Now, my friends of x is 3 over 2, so how do I get rid of it? I'm going to multiply both sides by 2, because 2 over 2 is 1. Those guys cross out. So I'm just going to be left with 3x is equal to -6. And then you guys again should know what to do here. Divide both sides by 3. So x is equal to -2. Now we know that this is correct because we did it graphically, but we have our x value algebraically now. So now I need to figure out what my y value is. If I already have my x, the only thing you actually need to do is just plug it back into one of your original equations. And we'll talk about why you want to plug it into one of these two instead of this afterwards. So I'm going to use the second one because it's much easier to do. There's no fraction there. So my x value was -2 in this case, plus y is equal to -6. So y is equal to -6. When I bring the 2 over, it becomes positive. So -6 plus 2, y is equal to -4. When you do the check, again, it's the same thing. You can plug them in and see whether your left side equals your right side, but we know that this is correct because we did it graphically before. So why should you sub it back into either of the original equations and not the one that we arranged into slope y-intercept form? The main reason why you should always put it back in the original, and this goes for any question, is because if I converted this wrong, your whole y value is also going to be wrong. So you always want to put it into one of the originals because that mitigates your chances of mistakes. And that's it. Class fun is listed here. Please remember that you have a Chapter 5 linear systems review. You might have to do some of this at home because we only have one review day. And your Chapter 5 test is March 9th or March 10th. And if you're going to be away, you got to make arrangements with me to write it earlier because you're not going to be writing it after March break. That does not help you at all. Thanks. Bye.